Hello and welcome to SuperGrads. Today we'll be discussing polynomials, which is very important for CMAT and for all the other management exams, even MAT. So, what's a polynomial? Now we need to understand that can be of different orders. So, if I talk about the first order or first degree, so we will have the independent variable x with a coefficient, let it be a, and b will be the constant term. If I add them up, I'll get 0. This is the first degree polynomial, which is also called as linear equation. Similarly, if I take the highest degree of x to be 2, so highest is 2, x can be 1 as well. Both will be having some coefficient. So a is the coefficient for x squared, b for x, and a constant term. This will be a quadratic equation. Similarly, and keep on increasing the degree, and we keep on getting different expressions like this. Now we need to understand and we need to learn that how these things actually behave. So the values which will satisfy this equation would be known as roots. Be known as roots. Now, what is the relation between roots and the expressions? That is what we're going to understand. So for that, let me first take linear equation is something which is very simple. So let us take the quadratic first of all. Ax squared plus bx plus c equal to 0. Now, if there are two values, let us say alpha and beta, so at x equal to alpha and beta, this is satisfying. Now, alpha and beta are the roots. At the very same time, if I move alpha towards left hand side, that is x minus alpha equal to 0 and x minus beta equal to 0. So in this case, x minus alpha and x minus beta will become the factors of this expression. Now, if I multiply them, x minus alpha multiplied by x minus beta equal to 0. The product will be 0 because both the values are equal to 0. Now let this be equation number 1, and expanding this, we'll get x squared minus of alpha plus beta times x plus alpha beta equal to 0. Great. Now what? We need to compare these two. For comparing these two, I need to divide the equation 1 by a, and I'll get x squared plus b by a times x plus c by a equal to 0. Now, why I did that? I did that so that the coefficient of x squared becomes 1 in both the cases. Now, if I compare, I'll get to know that alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. So normally people call this sum of roots, and this is called as product of roots. But now we'll be using a new terminology that will be sum of product of roots taken n at a time, which means if I write SOPOR 1, that means sum of product of roots taken one at a time. So I took one root at one point of time, that is alpha or beta. This is equal to alpha plus beta. Now, if I take SOPOR 2, so two roots taken at a time, we have only two. There's only one element possible, that is alpha beta. Now you'll get a clarity the moment we move on to the higher degree polynomials. So let us take a cubic third degree in which x minus alpha, x minus beta, and x minus gamma, let them be the factors. We multiply them, I get 0. By the way, alpha, beta, and gamma will be the roots. So now if I multiply them all, I'll get x cubed minus of alpha plus beta plus gamma x square. So as you can see here, one root is taken at a time. This is sum of product of roots taken one at a time. The next will be taken two at a time, alpha beta plus beta gamma plus gamma alpha times x. You need to understand that here we have minus, here we have plus. Why it happens? Because if I take minus alpha or minus beta or minus gamma, minus is common. But now if I take minus alpha and minus beta together, two negatives make a positive, so that is why it is positive. If I take all three at once, it will definitely be negative. Minus alpha beta gamma is equal to 0. So here sum of product of roots taken one at a time, that is this, alpha plus beta plus gamma will be equal to minus b by a. Sum of product of roots taken two at a time, that is alpha beta plus beta gamma plus gamma alpha will be c by a, and SOPOR3 taken three at a time, that is alpha beta gamma, this will be equal to minus d by a. Now what is a, b, c, and d? For that, let us write a general form of a third degree equation, which is ax cube plus bx squared plus cx plus d equal to 0. So what we did in the earlier slide, the same thing we'll be doing over here as well. So if I divide everything by a, I'll get x cube plus b by ax squared plus c by ax plus d by a is equal to 0. Now if you compare this with this, you get to understand that what exactly is happening and how we have got these results. So this keeps on increasing. Now, no prizes for guessing. If I take a biquadratic expression, that is fourth order, then what we'll be having? There will be four roots, alpha, beta, gamma, delta. Let them be alpha, beta, gamma, delta. And the same thing will happen then. So if we have fourth degree, the equation will look like ax to the power 4 plus bx cube plus cx squared plus dx plus e equal to 0. By the way, they don't normally go above 3, but just for making you understand, I'm taking 4 degrees as an example. Dividing everything by a, I'm just reiterating everything that I did in the earlier few slides. This is what I get. And now this happens to be my standard equation. Let this be equation number 1. And as I'll be taking alpha, beta, gamma, and delta to be the roots. So x minus alpha, x minus beta, x minus gamma, and x minus delta happen to be the factors. To multiply them all, I'll get 0. So alpha, beta, gamma, delta are those values, the roots, which will satisfy this expression. Great. Now if I expand this all, what I'm going to get? Sum of product of roots taken one at a time. This is alpha plus beta plus gamma plus delta. That'll be equal to minus b by a. So it remains same in all the conditions. The only thing that we have to take care about that this sign will keep on alternating. Minus plus. The next will be minus automatically. And then plus. So now we have understood that what is the relation between the roots, their sum of products to the actual expression. That is all about polynomials. Now, how a question can be asked on this? Normally, they can ask you to find out the roots. So let me give an example. The example is x cube minus 6x plus 11x minus 6. Here we have square equal to 0. Now I need to find the roots of this expression. How to do that? Okay. To find the roots, there are certain rules that we need to follow. The first rule is that we will try to look at the sum of the coefficients and the constant terms. So of coefficients here is minus 6 plus 11. Here we have plus 1 as well. 1 minus 6 plus 11 minus 6. This is equal to 0. Now this is equal to 0. What does that mean? That if x was not there, the sum will be 0, right? X was not, the sum will be 0. So how can we eliminate x? By putting x equal to 1, which means at x equal to 1, this equation satisfies, so now need to understand, just note it down somewhere, but if the sum of coefficients is equal to 0, then 1 is going to be a root. At the same time, x minus 1 is going to be a factor. Sometimes we tend to check for putting, if this doesn't happen, we'll put x equal to minus 1. So we keep on doing that. And if this term is not there, then x equal to 0 will be one of the roots. Why? Because if you put x equal to 0 and this constant term is not there, then x equal to 0 satisfies the given expression. Now we are clear about this thing. X minus 1 is a factor and the order is 3. There need to be 3 factors. How to get the others? Okay. So Sum of product of roots taken one at a time, one at a time. Now one, so there are three roots, alpha, beta, gamma. In this case, we already found one, that is one. So one plus beta plus gamma, this will be equal to minus b by, which means six. Or we can say beta plus gamma is nothing but five. Similarly, sum of product of roots taken two at a time, that is one times beta, one times gamma, and beta times gamma. This will be equal to this C by A, which is equal to 11. So now we have this with us. By the way, beta plus gamma is 5. We can put it over here and I'll get 5 plus beta gamma is equal to 11, or simply beta gamma is equal to 6. By the way, if I took all of them together, I would have got the same result. 1 into beta into gamma, that is equal to minus of this 6. So we got the same value. Now beta plus gamma is 5 and beta gamma is 6. By calculated logic, we can say that 2 and 3 are two such numbers which, when added, give 5, and when multiplied, give 6 as the resultant. So we have 1 as one of the roots, then second is 2, and then we have 3. This is how we use this entire generalized method. Great. So far, so good. Now, let us go to the second part of today's session, that will be graphs. They can give you a graph and ask about that what is the exact expression of this graph. Am I audible? If someone is watching me, just tell me in the comments. Do you understand it? Coming to graphs. So let us start step by step. Today you will be able to understand everything about graph. The first is, now if I have to make a graph, for example, simplest graph, x is equal to 5. Now what does that mean? Here y is absent, but x is there. So there's x-axis, there's y-axis. X is equal to 5. So at this point, which happens to be 5 comma 0, there'll be straight line. Why? Why? Because x has to be 5 and y can be anything. It can be anything. So we get a straight line. Similarly, if I write y is equal to 5, what's going to happen? At this, we'll get a straight line where this point will be 0 comma 5. So y is 5, x can be anything. This is the simplest graph. Now let us try to complicate the graphs now. So next, I'll take a linear equation in which x and y both will be present. So let's say 2x plus 3y is equal to 12. Now, to draw the graph of such linear equations, the best way to draw is to divide this whole by this term. So if I divide by 12, I'll get x by 6 plus y by 4 is equal to 1. Now, the moment we get it, this 6 will be the x-intercept and this 4 will be the y-intercept. By intercept, what do we understand? We mean that the graph will cut x-axis at 6 and y-axis at 4. So this is how it will look like. This 6 comma 0 and this one is 0 comma 4. Chalo. So far, so good. We'll keep on doing this. Similarly, if I move to quadratic expressions, so let's say the expression is x square plus 5x plus 6 equal to 0. Now we draw a graph. We always have to remember that for a quadratic expression, it always becomes a parabola. A parabola. So if you break it, this is x plus 2 multiplied by x plus 3 equal to 0. All right. So the moment we put x as minus 2 or x as minus 3, we'll get 0. That means minus 2 and minus 3 happen to be the root. So graph will look like this. This is minus 2 and this one is minus 3. And this will be equal to 6. This is how parabola look like. Now the parabola can be facing downwards as well. We can have a parabola like this as well. So whenever we have this kind of parabola, always the coefficient of x square will be negative. So for a general quadratic expression ax square plus bx plus c, whenever we try to draw a graph, it will always be a parabola upward facing if a is greater than 0, but if it says a is less than 0, it will be downward facing. That is how we draw the graph. All right. Similarly, Let's say it's a cubic expression. For example, x cube plus 6x, x cube minus 6x squared plus 11x minus 6 equal to 0. So in this case, we have one, two, three roots are there, as I told you earlier as well. 1, 2, and 3. Graph will graph will intersect at x equal to 1, at x equal to 2, and at x equal to 3. Now the graph will, before 1, it will be where? It will be upwards or downwards. That is what we have to understand. So to understand that, we will put x, as you know, this is x equal to 0. If I put x equal to 0, I'll get minus 6. So graph will be starting from here, 0, comma minus 6. And then it will go intersect 1, go upwards, then it will go down because it needs to intersect 2 as well, and then goes upwards. So this is how the graph will look like for the cubic expression. I hope this is clear to all of you. All right. Now, the next thing which is important is the graphs for modulus. In modulus, what actually happens? So if I take the very simple linear equation, which we did earlier, 2x plus 3y equal to 6, and then someone puts a mod over it. Someone puts a mod over it. Clear? The graph look like this, 3 comma 0 and 0 comma 2. The moment you put a modulus, automatically, automatically what happens? Whatever is negative will translate into positive, which means this part will be cancelled and automatically the graph will translate to the upper side, that is the positive side. That's what happens in modulus. So I'll give you for three more examples. Let's take a quadratic expression. So let's say the expression is x squared minus 5x plus 6, and there is a mod. How to draw the graph of it? First of all, we'll draw the normal graph without modulus. So the idea to draw it is to draw this first of all without using the mod. So as we can see here, that 2 and 3 happen to be the roots. This is how graph would have looked like if it was without modulus. The moment we put a modulus, so whatever is positive remains positive, whatever is negative transforms into positive at the in the same fashion. This becomes like this, and this whole goes away. This will be the graph for modulus. So whenever you have a modulus, always try to just transform the negative to the positive. Let's take a few more examples. So if I have something like fx is equal to x cube minus 6x squared plus 11x minus 6, and then we have a mod. Here the roots are 1, 2, and 3, which we discussed earlier as well. So ideally, the graph would have looked like this. If this was 1, this was 2, and this was 3, and this thing is minus 6. Now, we put a mod. So automatically, all the negative parts will just go away. This one goes away. And the graph transforms to the, all the negatives go become positive like this, and the positive remains positive. So new graph looks like this. So that's the beauty of modulus. Everything that is negative becomes positive automatically. Wow. Now, let us try to understand graphs of few more expressions, few more algebraic expressions. For example, the graph of logarithms. So logarithms, what happens in logarithms? Let's say fx is equal to log x. When the base is not given, we normally consider the base to be 10. Consider base 10. Why 10? Because we humans normally do all the calculations. Our number systems, the decimal number system, which is commonly used as, has 10 different digits, considering base 10. So see what is going to happen. If x equal to 0, if x is equal to 0, it's not possible at all. Why? Because there is no power, there's no power of 10 which can give 0. 10 to the power anything cannot be equal to 0. That means the graph would not exist on this axis. The graph will never touch this axis. All right, because x can never be 0. Okay, that is something which we understand. Now, if I take this draw table, x equal to 0, so this is not possible. Now, if I take x equal to 1, log of 1, so which power of 10 gives 1 power 0? 10 to the power 0 is equal to 1, right? 10 to the power 0 is equal to 1. So, what does that mean? What does that mean? That if the value of x equal to 1, let this be 1 comma 0, then the value of the graph, the value of fx will be, fx is this, y-axis, this is x. So value of x will be 0 at that point of time. Okay, so graph has to go through this. That is something which we understand. Now, if I take x is equal to, let's say, 10, log 10, so 10 to the power 1 is 10, log x will be 1 in that case. So if I take 10 comma 0, graph will be somewhere over here, 0 comma 1. So now if I draw the graph, it will look like this. By the way, in logarithm, there's one thing which we need to understand, that the rate at which graph was growing was very high earlier, and it became the rate at which the growth was happening became very low. Once we keep on crossing 1, then 10, then 100. So for 100, log 100, this will be 2. Now you can understand that here we moved 90 steps, here we moved only one step. Here we moved 9 steps, here we moved only one step. So the rate at which x grows, the growth in y, the growth in log x is very low, but it's very high before 1. So as you can see, from 0 to 1, the graph has grown infinitely, isn't it? Why is it happening? Why infinite growth is there? I'll tell you. So if I put x equal to 1 by 10, 1 by 10 is nothing but 10 to the power minus 1. All right. So log of 10 to the power minus 1 is nothing but minus 1. So 1 by 10, which was a fraction. So if 1 by 10, let it be here. This was 1 by 10. At this point, the graph was at minus 1. So as you can understand, if I keep on moving towards 0, towards this point, the graph will keep on moving towards negative infinity. And infinity doesn't exist. That is why the graph will never be able to touch the axis. Now we understood that. Coming to modulus. The moment I put a mod over it, all the negatives will transform into positives. So as you can see, this one is positive, remain like this, but this will go like this, and this whole will be over. So that is how the graph of mod of log x will look like. In CMAT exams, they can give you a graph and ask you that what will be the correct answer for this graph. This can be a graph given to you. Answer is will be mod of log x. By the way, there are other kind of graphs. You can do one thing, put the value of x to be 0, 1, 2, 3, and check the corresponding values of y and mark the correct answer. So that is how it can be done. I hope you understood all of this quite well. And if there are any doubts, you can put in the comments. By the way, we are not going deep into it because we assume that you already cleared CAT and prepared for CAT. But whatever is required for CMAT, we are doing this in this series. Every day we have a series except Sundays. So today we did the graphs and the polynomials. This much was sufficient for uh, CMAT, and I hope you enjoyed the session. Tell me in the comments. We'll come up with more such sessions. Thank you.